So in section 5.4, you're going to be finding probabilities, which is what you did in section 5.2. But instead of finding probabilities for individual data values like a height or a selected speed, one value, you're going to be focusing in on taking a group of values or sample and looking at a probability for the mean of that sample. Now, the first thing that you're going to do when you want to work with a sample mean is you're going to check to make sure that one of the two properties here from the central limit theorem are satisfied. Now, what these two properties state, the first one says when you look at your sample size, and you should remember that n represents the number of values in your sample, your sample size needs to be 30 or more in order to be able to use the normal distribution. So if that's the case, we'll have nothing to worry about, and we'll go through the process of using the normal distribution. If that is not the case, so if we are taking smaller samples, say our sample size is 20 or 15, then we're going to have to make sure that we are given that the data follows a normal distribution. So again, this is an either or. We're going to check to make sure one or the other of those two things is met. And then we're going to look at coming up with the correct mean and standard deviation. All right, now you're going to notice these have a little subscript of x bar. That just means we're now talking about a sample mean versus an individual data value. Now, when it comes to the overall population mean, that will not change, whether it's an individual value or a sample mean value. What will change is the standard deviation, and when you're dealing with sample means, it's going to have to be recalculated by taking sigma over the square root of n. So what this is going to do for me is give me the information that I need to calculate probabilities, which you should remember that probability is just finding the area under the curve for sample mean values. So let's take a minute first here. Let's go back and review. In section 5.2, we defined a method for finding the probability for an individual value of x. All right, and in that method, what we did was we transformed our value into a z-score using our basic z-score formula. All right, subtracting the mean mu, dividing by standard deviation sigma. That z-score allowed me to go to my table, and then using the table, I was able to find area left, right, or in between. All right, now again, when we talk about doing this for x, we're talking about looking at a probability for one selected data value. All right, now again, in 5.4, in this section, what we want to do is apply that same concept to working with a value of x bar, which is a sample mean. Now the process is not going to change. We're still going to convert to a z-score. We're still going to use our table to get the area. But when I'm dealing with a sample mean, I have to remember that my standard deviation has changed and is now sigma over the square root of n. So a change in standard deviation, but again, the point of the z-score is to be able to go to the table, and the table will give me the area under the curve. All right, so here's our first example, and what I'm going to do first is just read through, like I always do, and pull all the given information. So the first thing I'm given here is that the mean annual salary, that would be my overall mean mu, is $65,700. Now, the next sentence should be the first thing that kind of jumps out at me as far as knowing that I'm going to need to use this slightly different standard deviation, because notice I'm not asked to look at an individual value, not one flight attendant, not one salary. I'm asked to look at a sample of 48. All right, that's the first big difference to note here. The second thing that should jump out at me is while I am asked to find probability, which we've done, I'm asked to do this for a mean salary, not one value, all right, but a mean salary. And the mean of a sample means I'm going to be working with a value of X bar. So the question here says find the probability that a sample mean salary, X bar, is less than $63,400. Now, like I said, when you're going to work with sample means, the first thing that you're going to do is check those two properties that were given by the central limit theorem to make sure one or the other is met. So if we just refer back to our central limit theorem, right, the two properties, either the sample size is 30 or more, or you're given a normal distribution. Well, our sample size here was 48. So that first property is satisfied. Sample size is 30 or more. That tells me that I will be able to use a normal distribution. So if I wanted to sketch this out like I've done in the past, sample size greater than 30 tells me the sample means the values of X bar will follow a bell-shaped curve. And then I'm going to look at the defining values. Both of these in terms of the sample mean X bar. Now, like we saw in the central limit theorem, the overall mean will be exactly the same, whether it's for an individual value or a sample mean. But the standard deviation is going to have to be recalculated. Instead of using sigma, that would be for individual salaries, I'm going to take sigma divided by the square root of n is my sample size, which is 48. So I'm going to go ahead and estimate this. Go ahead and just plug it into my calculator so that I know what standard deviation I'm working with. I'm just going to make sure not to round it too short because I'm going to have to use it again. So I would keep this out to at least 4 decimal places. All right, so if I want to get an idea of what I'm looking for, I'm asked to look at a sample mean of $63,400. So that's going to be somewhere here below center, less than 65,700. I know that probability means I'm looking for the area under the curve, and probability less than corresponds to an area to the left. So the area of this shaded region right here is what I need to find to get the corresponding probability. All right, now, if I'm going to use my table, I have to have a value of z. So using the same method that we've defined in the previous section, in section 5.2, to get my z-score, I'm going to take this sample mean that I want to look at, 63,400. I'm going to subtract its mean, which was 65,700, and I'm going to divide by its standard deviation, which, because this is a sample mean, is not sigma. It is sigma over the square root of n. Now, when we calculate z, we round it to 2 decimal places because we want to be able to take it to our table. So I'm looking at a z-score here of negative 1.10. Now, the whole point of a z-score is to be able to go to my table. So I'm going to take this z-score to my table. Here's negative 1.1, 0 in the second decimal place. And that's corresponding to an area of 0.1357. So what I want to remember about my table is that it always gives me an area to the left. If that's what I want, then I'm finished. If I want an area to the right, I would of course have to subtract from 1. So I go back to look at my question. I was asked to look at values less than, which is an area to the left. So this value that I see in my table, 0.1357, is the area to the left, which is the same thing as the probability less than. So about 14% of the time, 13.57%, a sample mean salary for 48 flight attendants will be less than $63,400. Now what I hope you can see is that this is the exact same method that we defined in section 5.2 for finding the area under the normal curve. The only difference is while you use sigma to look at an individual data value, you use a different standard deviation, sigma over the square root of n, when you're looking at a sample mean. And because this method is so similar to what we did in section 5.2, if you want to use the StatCrunch calculator for the normal distribution, you can certainly do that as well. You would just need to make sure that you put in the correct standard deviation when you went to use that normal calculator and find the probability. All right, now, just to give you a second example, I went ahead and walked through the second example with you here. And again, what I hope you can see, the first thing I do is I note, I'm taking a sample, a group of values. I'm looking at a probability for a mean. So I check my central limit theorem. My sample size is 30 or more. I recalculate my standard deviation, sigma over the square root of n, because I'm looking at a sample mean. I use that to get my z-score, and I take my z-score to the table to get the corresponding area. And then here, table gives me area left. I wanted greater than, which is area to the right, so I finished by subtracting from 1. So all the things that you know already about finding area left, area right, even area in between, those are all still going to hold true. They're going to be exactly the same as what you have seen before. Again, all you're doing differently here to find probability for sample mean is you're changing the standard deviation to sigma over the square root of n.